Hello everyone, I'm Johnny. I'm a product data scientist in SurveyMonkey. Today, I'm going to talk about the recent work that we did in automated double-barreled question classification using machine learning. I will first give an introduction about what a double-barrel question is, and then talk about the objective of our work. Then I will walk through the data part and the machine learning pipeline that we developed to classify double-barreled questions. And finally, I will present the results. In our daily life, we ask a lot of questions to find out what others are thinking. For example, do you like Iron Man? How often do you argue with your boss? Are you satisfied with our customer service? As survey researchers, we are trying to design unbiased questions as many as possible so that we can find out what a person thinks towards the subjects of matters. Biased questions may lead to response bias, such as extreme response. Eliminating biased questions requires careful manual work, which sometimes can be tedious. However, we still want to remove them because this can improve survey quality, reduce confusion, and increase survey completion rate. Among all types of biased questions, double-barreled questions is one of the most common types. It is defined as a question that has more than one part. What it means is that there can be no way to tell which parts of the questions the response refers to, given that the answer option choices are simple enough that do not indicate which part of the questions are referring to. Here are the two potential examples of double-barreled questions. The first one is, how well do you get along with your managers and coworkers? If the answer options are well, not well, and neutral, then if I get along well with the manager but not with the coworkers, I will not be able to express my opinions properly in these questions. The second example I want to talk about is, do you agree with the statement that cars should be safer and faster? What if I only agree the first part, which is cars should be safer, but not the second part, which is cars should be faster? Should I still answer agree or disagree for these questions? Although the double-barreled questions is common, there is limited research work in automatically detecting the double-barreled questions. The current state-of-the-art method is to identify the existing of grammatical conjunctions to detect double-barreled questions, such as finding the and token in two examples. This rule-based approach can be error-prone because it is not generalizable to all cases, and there is limited work in developing machine learning approaches to classify double-barreled questions. Some examples that grammatical conjunctions won't work are, for example, are you aware of any students or professor doing this? Or, how much do you like the show Tom and Jerry? Obviously, Tom and Jerry is a phrase. However, if we use this rule-based approach, it will misclassify the last question is the double-barreled questions. In this work, our goal is to develop machine learning models to classify double-barreled questions, which should be better than the rule-based approach. Another goal is to make the models available in our SurveyMonkey survey platform, which detect possible double-barreled questions in a survey and make recommendations to our users. And here is a screenshot of what the recommendation will look like in our platform. And just a note that we have already filed a patent on this invention. Since we're using supervised methods to train the machine learning models, we need labeled data for training. We first collected a set of questions and answer options in our database, which were split into train, validation, and test sets. Then we have our survey researchers to label the data, and we performed a series of preprocessing steps, such as lowering the case, remove test constructions. We use only English data. In machine learning model training, we need to create some features from the question text data so that we can use them to train the model. Now, I'm going to talk about two major classes of methods that we can create numerical features from the raw question text, which is, do you like chocolate? The first class of methods is called work level embedding. Using this type of method, we can convert each work token into a numerical representation. We call these numerical representations as feature vectors. Then, we can combine these feature vectors using mathematical operations, such as the max operations, to generate the final representation for the question text. The second class of methods is called sentence level embedding. It is similar to the work level embedding, except that we don't convert work tokens into numerical representation individually. Instead, we convert them together into the final representation for the question text. Using these two ways of generating features, we can now build a classification pipeline to detect double-barreled questions. Briefly, we first collect a set of questions and answer options. Then, we use the word level and sentence level embedding methods to convert the text into numerical feature representations. Then, we can use these features to train machine learning models such as random forest to classify double-barreled questions. To evaluate the trained models, we look at a variety of machine learning evaluation metrics to make sure that our models are robust in balanced and in imbalanced dataset. This includes recall, precision, specificity, and the area under the ROC curve and the area under the PR curve. Here are some of the result highlights. First, we observed that the machine learning models achieved more than 10% improvement in precision and specificity than the rule-based approach. Second, one of the flexibility that the machine learning model can offer is that the models can tighten the classification by adjusting the probability cutoff requirement to classify a question as a double-barreled question or not. This can ensure that a recommendation we make and present to the user interface is more likely to be the true positive. Third, overall, the machine learning models achieved more than 0.5 AUC under the PR curve and 0.8 AUC under the ROC curve. Here is an example of true positive classification, in which the model classified the double-barreled question correctly. The question is, do you feel that the central office administrators listen to you, your concerns, and attempt to remedy those concerns? And the answer options are yes and no. We also innovated a new visualization technique based on sharp value to understand the black box classification. In here, we see that among all the tokens, the N token has the highest value, which is indicated by the dark blue color. This shows that N token contributes the most to the positive classification. Here is an example of the true negative classification, in which the model classified the question correctly. The question simply is, choose your current specialty. And obviously, this is not a double-barreled question. To conclude, in this work, we developed an end-to-end machine learning approach for double-barreled question classification. And the proposed approach performs significantly better than the rule-based approach. Here is the list of reference for the research work. And that's it for the presentation. Thank you very much for your attention. You are very welcome to send me any questions about the presentation or simply just find me for a coffee chat about data science and machine learning. Oh, also, we are hiring, so please check out our career page for more information. Thank you.